That our ancestors, lived on this diet, that they only ate meat products. That is not true. Whatever goes on within the brain, also the gut knows it. The gut knows it, and the gut responds to it.
Dr. Emeran Mayer is a distinguished professor in gastroenterology and neuroscience and recognized as a leading expert in the gut-brain axis. He's also a professor in physiology and psychiatry. Dr. Mayer, it's an honor to have you, and thank you very much for accepting the invitation.
Yeah, thanks, Faris, for inviting me. It's an honor. As I said, it's the first time that I do a podcast with a host in the Middle East, so I'm
Well,
looking forward to it.
Thank you very much, and we're very happy to have you here with us. And my first question is about the gut-brain axis. What is the gut-brain axis, and what are the most common diseases that are linked to it?
Yeah, just a quick correction. So most people talk about the brain-gut axis or the brain-gut microbiome axis, which implies there's a one-way communication between these organs. In reality, from what we have learned, it's a complex system. It's not just in one direction, it goes bidirectionally. And then there's a lot of feedback loops in these communications. And it has all the characteristics of a complex system. So people talk now more and more in biology about systems biology, that complex connections play a role in the regulation of our health, metabolic health, immune health. There's no single axis, but if I expand on this concept that's been promoted and a lot of people talk about it and write about it, it refers to the communication between microbes living in our gut, trillions of these microorganisms, not just bacteria, but also viruses and archaea and other microorganisms, that they can communicate with cells in our gut, and that our gut, with the help of these microbial inputs, can communicate with the brain. But that's only one side of the story. The brain also, we've known this actually for longer, has powerful influences on that it sends down through the autonomic nervous system, on every function of the gastrointestinal tract, contractions, secretions, blood flow, and also even on the microbes. So it changes the habitat of the microbes when you're stressed or when you're happy, and the autonomic nervous system can also talk directly to the microbes with its neurotransmitters. So it's when you think about it, why we have such a system, it actually makes a lot of sense because there's a long evolutionary history of microbial organisms communicating with the human host, generally in a beneficial way. So this is not about infections or the negative things we know about, pathogens. This is about homeostasis or, general health. So the microbes definitely are a essential component of that system. My original interest was just in the brain-gut communication. There was enough interest there because, I had a long-standing interest in chronic pain and in the role chronic stress plays in this. And these situations all have this important component that whatever goes on within the brain, also the gut knows it. The gut knows it, and the gut responds to it. For most people, that happens without conscious awareness. So when you're happy, you don't think about your gut. And when you're angry, most people don't think about their gut either. But if you a person that's more sensitive to events that go on inside of us, so we call this interoceptive sensitivity, then you will feel this, like all the emotions, sadness, anger, um, jealousy, and so that indicates that a lot of things that go on in the brain, like chronic stress effects, um, like irritable bowel syndrome, depression, anxiety, autism spectrum. So any of these diseases that we have studied primarily at the brain level, we now know often from animal models, sometimes from human studies, that they also have a component in the gut. And I think there's a lot of effort nowadays going on because our therapies have not been that successful in these chronic brain disorders. Let's also look at the gut and the brain-gut communication, how it's altered. Um, and then if you turn it the other way around now again, this gut-brain communications, there's a lot of studies now that have shown associations. These are epidemiological studies, or so they typically compare a population that has a clinical diagnosis, let's say depression, anxiety, um, ADHD. So take any Parkinson's disease, Alzheimer's disease. If you compare a population that meets the diagnostic criteria for these disorders and compare it to a normal, healthy population without a diagnosed disease, then in many of these studies, people have seen differences in the microbiome. But that's an association. That does not mean that the microbes play any role in the causation of these diseases. I think we have to be really careful. There's a lot of mouse studies now that in animal models of these brain disorders that have shown microbial a role for the microbes, but in humans, that causality has not really been firmly established.
Could you talk to us about the gut immune system and its role?
Yeah, this is also something that a lot of people hadn't realized before all this discussion has been going on about the microbiome. So I mentioned earlier, there's trillions of these microorganisms in our gut. The largest numbers in the third part of the ileum, the small intestine, and the colon, and they live in the middle of, like, they're mixed with our stool or contents, but a lot of them also live in very close proximity to the surroundings of the gut. And here it's important to realize that the immune system, some 70% of our immune system is in the gut. It's not in the bone marrow, it's not in the spleen, it's in the gut. And because the gut is such the length of the gut creates a big space, like the space of a basketball field, and that's where all these immune cells live, just microns away from the bacteria, or which is sort of an amazing design property that nature has chosen, because it's also very dangerous. If our immune system and its sensors come in contact with the microbes, even benign or beneficial microbes, it rings the alarm bells. And the way this is accomplished, that there is the intestinal barrier, a very tight separation made up of epithelial cells, meaning gut cells that line the gut, and in addition, a mucus layer made out of carbohydrate molecules that normally completely separates anything that's inside the gut from these immune sensors that they're called dendritic cells that measure if there's any microbe inside the gut. So normally the immune system is not activated by the microbes, but if that barrier, the intestinal barrier, is compromised, that can happen in different ways. The most common one is that there's a thinning of the mucus layer. Then the microbes that are in the gut come in closer contact with the dendritic cells, the immune cells, and then they ring the alarm bells and call a cascade of events activating the immune cells, leading to a cytokine secretion. Then the cytokines cause a local inflammatory response, and that can compromise the tightness of the cells lining the gut, and that ultimately can spread into the systemic circulation. leading to a condition called um, um, endotoxemic, metabolic endotoxemia, um, which means you have an inflammatory environment in your blood. Even though you have no infection, it simply comes from this abnormal contact of the microbes with, and that often is related to a poor diet or chronic stress. And just like hypertension, that nobody knows if they have hypertension because it doesn't cause symptoms, a compromised mucus layer doesn't give you any symptoms. So you wouldn't know that you have, your metabolic endotoxemia is going on and it's stimulating your immune system on a ongoing basis.
You talk about that there is an endocrine system in the gut. Could you talk to us about this more?
Yeah, this is another surprise. Like when I started my career in gastroenterology, I came to UCLA because there was an institute there, the Center for Ulcer Research and Education, NIH funded, a research center. Some of the most famous gastroenterologists in the world worked there and trained there. And this was the reason I came to Los Angeles, to UCLA. And my mentor there, the late John Walsh, was interested in these hormonal cells that are in the gut. And the more people looked, the more these hormones they found located in the gut. So they were isolated initially from pig intestine and from biopsies in humans. And there's now at least 40 more of these hormones that are being produced by specialized cells called endocrine or enterochromaffin cells in the gut. And the the two most famous ones is GLP-1, because it's obviously the essential component of many weight loss drugs. Another component of these drugs is GIP, which initially was called gastroinhibitory peptide. I forgot what the latest name of that hormone is. But imagine the same principle. You have this basketball size surface in the gut, and it's sprinkled with specialized cells. So it doesn't have just the cells that we talked about earlier, the immune cells, but it's sprinkled with cells that are specialized in producing and secreting these hormones. And these hormones can act locally on, for example, on nerve endings of the vagus nerve and then send signals to the brain, or they can get into the systemic circulation and also reach the brain, but also reach many other organs like the pancreas. And so just these two examples that we talked about, the immune system and the endocrine system in the gut, give the gut a unique, in the body, a unique ability of communication with all the other systems and all the other organs. So I personally think if you try to compare this with the heart, which is a mechanical pump, or the lungs, which is a respiratory organ, has other functions as well. The gut is not just a digestive organ. It's the center of our called homeostasis or metabolic balance and immune balance that we have inside of us.
I would like to ask you a couple of questions about the diet. How important is dietary fiber, and what do you say to experts who claim that we don't need any fiber?
Yeah, so I mean, dietary fiber, this also goes back to the conversation about the microbes. So dietary fiber are complex carbohydrates. So simple carbohydrates are sugars, complex carbohydrates are larger molecules that typically, if the food is not cooked or processed, cannot be absorbed by the small intestine. So we don't have the enzymes or the absorptive capacity. So they are basically food for the microbes. They travel down when you ingest it. they travel down to the end of the small intestine and to the colon, and where the microbes basically start breaking them down into smaller molecules. So fiber is essential for a healthy microbiome and as a nutrition for the microbes. And the microbes produce something from these fibers that is a very important metabolite or molecule, which are these short chain fatty acids. The most well-known is butyrate. You can think of butyrate almost like it's the universal medicine in our system that is produced with the help of the microbes because it has anti-inflammatory effects. It stimulates growth of the intestinal wall. So it has many beneficial effects, not just in the gut, but throughout the body, including the brain. It's one of the most important anti-inflammatory substances. So, for example, I'll give you an example. If you're an unhealthy diet, an inflammatory diet, ultra-processed food, that ultimately can affect your brain and the immune system in the brain. You have inflammatory responses. But if you eat enough fiber molecules, you will generate a large amount of these anti-inflammatory molecules that counteract the negative effect. So a healthy diet is important, not just for the nutrients in it, but also that you help your gut microbiome to have the biggest diversity and this ecosystem, and also to make it allow it to produce these anti-inflammatory substances. So think about the aspirin factory in our bodies, which is always ongoing and suppresses inflammation wherever it shouldn't happen. So I always say, people ask, what's the healthiest diet? I always say, well, think about what's the healthiest diet for your gut microbiome. And that is a largely plant-based diet. And the reason for that is because a largely plant-based diet with fruits and vegetables has two types of molecules in it. One is the fiber, and there's really thousands of different fiber molecules. It's not just one kind of thing, and then there's another group of molecules called polyphenols. So these are the most well-known are in dark berries. Blueberries gives fruit its colors, but there's just one function. The other function is it's also food for the microbes, broken down into these smaller molecules which have these beneficial effects. So if you eat a diet high in fiber, it will not only improve your bowel movements, but it will have a lot of these secondary health beneficial effects. Now, your question, why would you eat a fiber-free diet? So, a lot of people talk about the keto diet, which is mainly meat-based and has very little, the original, there's modified versions, but in some ways for your long-term health, if you want to lose weight quickly, or if you want to, if you're a muscle builder and want to do this for a couple of weeks to build up your muscles, the fastest way, such a diet may not be bad, but it's not good for your health. It's absolutely, despite some people still defending this as a health promoting diet. There's a couple of exceptions. There's a condition, intractable seizure disorder in young children, where they have a seizure like every 5 minutes. There it's been shown that a keto diet without the fiber, just the proteins, is beneficial. That also has been shown in animal models of this disease. And then there's also talk about in advanced Alzheimer's disease or cognitive decline, it may also be beneficial. But for example, in inflammatory bowel disease, where this used to be promoted, a fiber poor or fiber-free diet it's changed 100%. There's now the recommendation, eat a Mediterranean style diet, which has now been shown in studies to be beneficial in patients with inflammatory bowel disease.
Would you say the more the fiber sources are diversified, the more your microbiomes will be diversified, and that will lead to health benefits?
Yeah, it's sort of a general principle in nature. I would say that most of these health promoting substances are come in large variety in nature. The polyphenols, hundreds, possibly thousands of these molecules, fiber, the same thing. And so if you eat a large variety of these plant-based foods that contain these, then that kind of indirectly forces or encourages your microbiome to add on more and more specialists that can break down these particular molecules. So it's just like a community. Initially in this community, you may just have one bakery or one small factory. If it grows, you want to do much more things, and so you need to add other specialists. And that's what we want in a healthy ecosystem. We want to have as many specialists being present that all interact with each other and create a stable system. The more diverse a system is, the more stable it is. So the more diverse your food sources are, the more diverse your microbial composition is, the more stable your gut microbiome uh, will become. And that is a measure of gut health. And, it's been shown in many studies preventing like chronic diseases, that kind of a diet.
Are ketogenic diet or carnivore diet, which eliminates fiber or have very little fiber, harmful to the gut health?
It's definitely not healthy. It's not healthy for the gut. I mean, that is absolutely clear. Um, and there's, so one of the justifications of the carnivore diet um, is always that our ancestors, lived on this diet, that they only ate meat products. That is not true. It's if you go back to many um, societies and people that like even prehistoric. So there's a few remnants of these populations in the world, and in the Amazon jungle and in East Africa that still adhere to um, these early forms of diet. The main composition is berries, leaves. It's plant-based, and often these societies or these peoples, they they eat meat in moderation. Like, I mean, I personally spent time on the Orinoco River, in the Amazon, jungle, and these people, so the natives, are surrounded by wild animals, so they could basically be carnivores if they wanted to, but they only eat a small amount they kill only a small amount, and the main meat sources are fish and birds and wild birds, not the big mammals that are running around. So they have learned to live of probably a 70% plant-based diet, supplemented by meat sources that are not the big mammals. And it's interesting when you go back in history, that seems to be a general pattern. There's always some exceptions, but it seems to be a general pattern. Now, modern agriculture has obviously has changed this pattern because it provides easy access to meat and dairy products, but that's not the ancestral diet that humanity has developed into. And I think what we do now is we go back, so we pick like the Mediterranean type diet, but it's not just the Mediterranean diet, it's also, you find similar things in Okinawa and in Asia and in other parts of the world. And it's similar to the ancestral diet, not a carnivore diet. So, but despite of what I told you, there's there's people that just won't accept that. They like the idea that we're carnivores. We we should eat as much meat as possible, and all the other things are not, are not important in our diet.
I would like to ask you a few questions about mental health or mental disorders and its relation to the gut. And for many who don't know that, on top of gastroenterologist, you have also background in neuroscience and psychiatry as well. So from neuroscience standpoint, could you talk to us about the two stress pathways, the amygdala and the cortex, and how to deal with both, and if the gut plays any role into those two pathways?
Yeah, so the whole the whole interest in the gut in psychiatry is sort of been it almost spawned a new field of psychiatry called nutritional psychiatry, um, which is based on this concept that what we feed our gut has an influence on our mental states, and plays a role in anxiety and depression. And some people have taken this even further to, schizophrenia um, and I mean, there's clearly simple evidence to support this. So, for example, when the pleasure you feel when you eat a satiating, delicious meal, that's definitely a very strong positive emotion. And people forget this, that um, on the other hand, if you get food poisoning, it's one of the most miserable emotions that you have ever experienced. So this clearly shows you this connection between what goes on in the gut and in the brain. And some of these emotional responses are mediated by molecules we talked about earlier, by these hormonal cells in the gut and by inflammatory mediators. So that's the simple part. Then a series of studies have come out in animals, in mice, where people transplanted, for example, stool from a mouse with a depression or anxiety-like behavior. I mean, they don't really have depression or anxiety, but they show a behavior that's similar. That if you transplant that stool into a mouse that doesn't have its own microbes, then that mouse will adopt that same behavior simply from this transplant. And that has led to sort of an excitement of, so now we have a whole new area of potentially being able to treat and even to diagnose, mental disorders. In humans, we have very few, if any, causal studies that can be done in mice. We can't do these experiments. In humans, we have a lot of these correlation or epidemiological studies I mentioned to you earlier. You take populations with the disease and without a disease, and you see this difference in the microbiome. And my feeling is, and it's based on the initial example of how powerful gut events can be, what effect they can be on your emotional state. Um, that there's clearly this significant ongoing influence of signals from the gut to the brain. We know all the pathways. We know the hormonal. We know the vagal. We know the inflammatory. There's many pathways and molecules involved in this communication. But I think in humans, emotions are obviously much more complex than they are in animals. And emotional disturbances and emotional mental diseases are also very different from these animal models. In the animal model, you can isolate all the other factors, the variability, and focus on one thing. In humans, you have all these factors, the early life events in the life of a person, um, the chronic stress level, the diet, the exercise. I mean, so the gut is one factor that contributes to this multiple input to the brain and um, to these areas that are involved in the generation of emotion and the modulation of emotions. The vagus nerve, has gotten a lot of attention. That nerve is not just a signaling pathway from the gut to the brain. that many of these molecules in the gut use to signal, but it also has, we know this from vagal stimulation experiments, some positive effects on pain perception and on depression. And so clearly there is a pathway that we know plays a big role in gut-brain communication. And when we stimulate it, it has measurable effects on mental health. And I think that what you get with the vagal stimulation, electrical stimulation, there's just recently a device being approved by the FDA for doing that in humans. But if you compare this with the subtle influences that happen normally and with all these other things going on, electrical stimulation of your vagus nerve is a pretty focused, intense interference with that complex system. And that's probably why you can show beneficial effects. Whereas normally in studies, you always have to deal with all these other influences. Our brains are integrative machines that take thousands of influences from the body and from our environment to generate what the ultimate output, which could be an emotional state. You ask about the amygdala and the prefrontal cortex. So the amygdala, definitely the part of the brain that has been best studied in terms of anxiety and fear and stress responses. And the prefrontal cortex, a major mechanism to decrease the reactivity of the amygdala, to control it. So you can have a mental disorder from an overreactivity of the amygdala, or from a insufficient inhibitory function of the prefrontal cortex. And both of these situations have been demonstrated in animal models, and we think that both are important in the generation of human emotions. I mentioned stress in terms of human emotions. That's also an important component. And the amygdala, obviously, and the prefrontal cortex play a big role in the stress modulation. An acute stress, the amygdala is activated. With chronic stress, that's not necessarily the cause. But there's circuits within the brain that are, these acute stress responses are very, very important for our survival as a human species, because if we didn't have, be scared by a snake, humans would have been bitten by 1,000 times by snakes. So we have an inborn mechanism of warning system. But then staying with this example, many people have learned to use their prefrontal cortex to suppress that response. And there's people that can actually pick up a snake, overcome this endogenous fear response by activating the prefrontal cortex. And this mechanism happens, for a lot of mental disorders.
And do you believe you can rewire those two pathways, the stress that are related to the amygdala and the stress that are related to cortex?
So the cortex is the human prefrontal cortex. Obviously, most animals have nothing similar to that very complex system. You can see that whole front part of the brain doesn't exist in many animals, certainly not in the mouse model or in the rats or the studies we do in these laboratory animals. But the prefrontal cortex can be modulated, and there's techniques for the most well-known cognitive behavioral therapy, where you basically retrain prefrontal circuits to respond different to stressful or fear-provoking stimuli. And there's one system within the brain that involves the prefrontal cortex, which is the salience network. It's a network that is constantly monitoring both your body, but also the environment for any potentially dangerous signals. And and it's monitoring it right now, while we're sitting here, but it also makes predictions about what's going to happen in an hour. So if you had to go in very heavy traffic in an hour, your brain would already make calculations about how should your body adjust to that. And but it can also do it like in the more distant future. What's going to happen to me in a week or in a year. People have called the brain the best prediction machine on the planet because of that, and it's also the principle of a lot of the self-driving cars. They have that same mechanism built in. That makes predictions of, and then decisions: should I stop at this signal or not? If this system is hyper responsive, as it is in quite a few people, so they make predictions for future events. So they, for example, think if they walk to a restaurant or drive to a restaurant, their brain already computes, am I going to be sick from eating a certain food? And that already starts activating these circuits in the brain, just these food-related anxieties. And so you can train the brain to respond more normally, not to ring the alarm bells. And so we call this stress hyperresponsiveness. It's partly genetic, partly influenced by early life experiences. So I don't know, people in the Middle East, if you did a survey, how many people would fall into this category. So in the US, from surveys, we think that about 20% of healthy people have that, what we call phenotype, the stress hyperresponsive phenotype, which is a failure to inhibit your salient system by the prefrontal cortex. And but if you go to patients with irritable bowel syndrome, for example, 40% have that hyperresponsive system. If you go to people with inflammatory bowel disease, a subset, I can't tell you the percentage now, a subset have it. And those are the people that are more likely to have flares of their symptoms. So very important function of the prefrontal cortex as part of this salience system that makes predictions. I mean, if you could name one part of the brain that, I mean, obviously all parts are essential for functioning, but this prediction system and salience network may be one of the most important ones for survival.
Yes.
Because otherwise we would walk through life like a sleepwalker. We wouldn't pay attention to any potential dangers and run into the next car and run out into the heat and die from heat stroke and like all these things.
Yes, I have heard this similar statement from a lot of neuroscientists that they say that the speech and the conversation that you have is mostly prediction, that your brain is just making prediction of what the next person will say rather than receiving. And I think psychiatrists and neuroscience should be more integrated.
Yeah, so this is not something. So even if you go to to therapists, like cognitive behavioral therapists, many of them wouldn't really be able to explain to you exactly what I just told you. That is,
Yes.
it's this reprogramming of your prediction system within the brain. Even people that do mindfulness-based stress reduction, I think it's a very important. I don't know how popular this is in the Middle East, but it's become very popular in the US as a strategy to deal with stress hyperresponsiveness. Essentially, what this is to force your brain to do less of the prediction, but focus on the moment. You want to focus your attention on the moment and sort of reduce this importance or this reliance on the prediction. And it's quite effective, as a stress reduction mechanism. But if you talk to people that that teach mindfulness-based stress reduction, not sure how many would actually give you that example of the prediction machine, you know?
Yes, it's a neuroscience concept mostly, right?
Yeah, yeah,
But
yeah,
it's very much related to stress, and if you understand it, it helps somehow to approach it. Uh,
absolutely.
yes, I have a question about meditation from neuroscientist standpoint. Is it possible to truly deassociate from the thought or create space between consciousness and the thought, or is that space a thought process by itself?
Yeah, I mean, this idea of of non-reactivity to, I mean, anybody who practices meditation or starts meditation will realize that your brain is full of chatter. I mean, the minute you sit down and want to meditate, thousands of thoughts go through your brain. And it's often difficult, certainly in the beginning, to not engage with some of these thoughts, you know. And so what you try to do in meditation to disconnect from this chatter,
Yes.
um, focus on one thing, like an easy one that many meditative practices use is focusing on your breath, just the inhalation and exhalation, and try to just focus on that. And anytime any thought comes up, you get rid of it through your exhalation, your breath out. Um, so you you take it in through inspiration, but then you let go. And if you do this on a regular basis, you will notice that much fewer of this chat will be that you'll perceive it. So your question, if I understand it correctly, would the chatter still go on, but now you don't pay attention to it anymore? You know, like you've trained your attentional system just to focus on your breath. This is all other stuff.
Yes,
I
and they believe that there is like a consciousness and there is the thought, and the thoughts are just passing and you're not engaging with them.
Yeah, I would just come from the experiential side, that if you experience this yourself, you know, you will notice all of a sudden that um, so it's not just the thought, it's like your body changes, your heart rate changes, your so this is really happening on the real level in the brain. It's not that the chatter goes on, but you're no longer consciously reacting to it. You know, I think it's um, why we have this mechanism that we've that this chatter goes on. It's probably because, I mean, the brain is the central organ where all the stimuli converge, and not just the stimuli in your actual moment, but also past experiences and projections of what may happen. So your brain is bombarded by three types of stimuli: memory, um, actual experience in the moment. So, for example, if it gets hot, yeah, your brain will feel this right away. And then projections, you know, and so you can imagine how much information that is that your brain is bombarded with. And I think the world that we live in has increased this tremendously with the 24-hour news cycle, which we didn't have before. You know, so this goes on. This takes up a big portion of our 24-hour awareness, and but I would say so I'm not a consciousness expert, but I would say it's not just creating a space or disconnecting your attention from what goes on in the brain. It actually goes beyond that. It calms that whole information gathering process within the brain, and at the same time decreases your reactivity. You know, you will no longer, your autonomic nervous system will no longer um, go up anytime you think about something. Oh my God, I forgot this. You know, so when you sit down for meditation, and then all of a sudden say, oh no, I forgot to turn off the hot water. You know, that won't happen when you're in a deep state of meditation. You know, you will not, you will neither perceive that thought nor will you react to it.
What are some other techniques that you recommend to help manage stress?
The simplest one that I recommend to my patients is this deep abdominal breathing. So most people that would sit in my practice and I would say take a deep breath in, or if they lay on the examining table, take a deep breath in, they would all breathe into their chest. I've not seen a patient who would not do that. Deep breath is associated with, for most people, um, inspiration into your chest. But that type of breathing is normally the stress type breathing, the fight and flight response breathing, that involves the sympathetic nervous system. Whereas if you teach the patient to breathe into your belly by essentially your belly expanding with each deep inspiration and then slowly exhale it, let that breath go out. If you do this even for a short period of time, and again, you need to get your mind into that. So it's partially the breathing, it's partially the focus, calming your mind. Um, then that will have a beneficial effect. So when I do this, so I've done this probably for most of my adult lifetime, particularly before stressful situations, or you can do it in the car. And I've tested this. If you measure your blood pressure before and after a 10-minute session of deep abdominal breathing, it will go down by at least 5 millimeter mercury, at least. I've seen it when I'm upset about something and do this, it could go 10, 15 millimeter mercury down. So it's a very powerful mechanism that we have built into our bodies. And it's probably related to the vagal stimulation. So breathe into your belly, it activates vagal sensory nerve fibers. They go to the brain in a part that tells the brain you're in a relaxed state. And the brain cannot be in two states at the same time, cannot be into stress state and relaxation state. So you essentially force the brain to go into relaxation. I think this is the most useful because it's simple to learn, it's simple to practice. You can do it anywhere. Um, you don't need any devices unless you want to see how your blood pressure changes. And we know the mechanisms. So I practice this myself as well. Is this progressive muscle relaxation where you basically also you lay down and you imagine that you're that you're totally relaxed. You start with the breathing, but then you also add this internal command. Your arms are getting heavy and your legs are getting heavy, and that heaviness is associated with a warm feeling. It's almost like some form of auto hypnosis. A little bit more difficult than the breathing, but if you practice it, you'll realize, and you can measure. It's not just imagine. If you measure the skin temperature on your arms, when you do this, it actually goes up. So there's increased blood flow to your extremities, and that further enhances the breathing part. So you can start with the breathing easily. Has to be regularly done 3 times a day, 5 minutes. Um, if you want to go further, you add the progressive muscle relaxation. If you go beyond that, mindfulness-based stress reduction, there's apps where you can learn this, or you can go to groups. Certainly in the US, there's many group settings where you can learn that. Um, yeah, I would say those three are the techniques that I would recommend.
How much of stress is shaped by genetics and early life experience, and how much control remains for adulthood through modifying choices and stressors? Is stress something that can be cured?
Well, I think cure is probably not the right word. And an exaggerated or in greater stress responsiveness that can be cured. Stress itself, like the stress response. You don't want to get rid of it. You want the stress response to kick in at the right
Yeah.
time and not constantly affecting your body. Um, so in our studies, we have found that trait anxiety, which is partially genetic, does play a role in the stress responsiveness. Early life experiences, so adverse early life experiences definitely play another important role, because they reset your warning system. So if you didn't grow up in a stable environment, and stable could be anything from your parents getting along and not fighting all the time, having both parents, um, your parents being healthy. So there's a lot of these things that can create an unstable early environment, and it goes all the way to traumatic stress. Like, I often think about like all these children that are in war zones and war situations. Um, that's almost like you would say, from what we understand, they're permanently damaged in terms of their stress responsiveness. Nobody talks about this, but I mean, they're not going to be normal, healthy adults. It's sad, and the numbers are obviously in the hundreds of thousands of kids that undergo this. So clearly, this shaping, both by genetics and early life experiences, is a very important thing. But because what we talked about earlier, our unique human prefrontal cortex allows us to create what I would say therapeutic patches. So you don't get rid of that overactive responsiveness, but you create something that you overlay, and it attenuates the responsiveness. Underneath is still the early programmed and genetically programmed abnormality. So you won't be able to cure that, but you can train something that's laid over this underlying problem. And that's kind of a unique ability of humans, that they are able to do this. Most of them, not everybody. Some people obviously go down a path of severe anxiety disorders, panic disorders, severe bipolar disorders. Um, but I think if you intervene early enough, um, you can reverse, not get rid of it, but reverse it and attenuate the stress responsiveness.
You have spoken briefly about ADHD. So, what is ADHD and what causes it? And is there a link between ADHD and gut health?
Well, there is. So it's attention deficit disorder, which is a very common, which is a very common abnormality in children. And there's a whole, range of symptoms around this, but there can also be hypermotility, but not being able to focus on one thing at a time, and jumping from one activity, from one thought pattern to another. Um, Something that's clearly exaggerated by the extensive social media use. It's shorter and shorter messages, like TikTok. So it started with Facebook, it's now TikTok. Kids don't want to listen or read anything that requires attention more than 5 seconds, which is really scary when you think about it. Um, and that has been associated, so a diagnosis of ADHD has been associated with IBS, for example. Um, People have tried to identify a gut relationship other than the association with digestive, IBS symptoms. Um, that's not been successful to pin down some gut microbial origin, or and probably diet by itself will not help with that either. I mean, yeah, I'm not sure the epidemic of ADHD that we're experiencing, and the alterations in brain function and reactivity that we're seeing, which will get worse and worse. Um, and when I just think about, my own youth, reading books was the key mechanism of learning and getting information. Now it's all these sound bites. That's the main source that people want, and they get bored anytime there's something longer than a few seconds. Um, that will actually, and I think it's been shown, have a neuroplastic effect. It will change the wiring of the brain. And if that happens early in life, I mean, if you walk around and you see infants in strollers looking at their at an iPhone as a distraction, so the mother, so the kid doesn't cry, or um, um, so it's almost like a pacifier. Mothers give the iPhone to the kids, and they already early on in life, when the brain is still developing, when the circuit is still developing, is exposed to that. And I think yeah, this will have major implications for future generations, and it seems hard to stop. I mean, some countries have started to prevent or to ban, iPhones from classrooms, and um, I don't know if that will help. Because it's like they're going to do it secretly. If you ban from the classroom, it's yeah.
Does any of the 85 to 90% of the serotonin that is made and stored in the gut, does any of it cross the blood-brain barrier or influence the brain?
This is a very interesting question. We could spend a whole hour or two to talk about it. So the origin of serotonin is tryptophan, the essential amino acid tryptophan. Tryptophan gets absorbed as a nutrient, by the small intestine. It goes to the liver, it goes to different organs, the immune cells, and it's metabolized into different metabolites. The only place where it's converted into serotonin is in the gut, in these enterochromaffin cells in the gut. So specialized hormonal cells that they're the only ones in the body. And 95% of the serotonin is therefore produced, synthesized from tryptophan, and stored in the gut. These enterochromaffin cells have a unique connection to vagal sensory fibers. So when serotonin is released, it can be released onto these vagal nerve fibers, and then the vagus sends a signal to the brain. But the serotonin cannot cross the blood-brain barrier. The serotonin is being taken up by platelets as soon as it's released, and there's no free serotonin level in the blood. And serotonin by itself cannot cross the blood-brain barrier. It signals through the vagus nerve to the brain, most likely in a beneficial way, but also, for example, with nausea, severe nausea, that's another serotonin vagal signaling pathway using a different receptor. So in general, we assume it's a positive effect. But serotonin also gets released into the gut. So on one side of the gut lumen, it gets to the vagus nerve. The other side gets into the inside of the gut and interacts with the gut microbes, who respond. So the gut microbes, they produce some serotonin, but they react to serotonin and change their behaviors. So a very complex story, but it's most people do not understand. It does not, like, if you have a lot of serotonin in your gut cells, that goes into your brain directly and makes you feel good. It's called this feel-good hormone. That's just not the case. It's the brain effects are mediated by this pathway of the vagal afferent pathway signaling to the brain.
But would it influence the brain indirectly through other mechanisms like the microbiomes and the signaling through the afferent vagus nerve?
Yes, I mean, that signaling to the vagus nerve, we talked earlier about these new devices, these vagal stimulators. So essentially, that's what serotonin would do. It would chemically stimulate the vagus nerve. But we can't really influence this. We can influence the vagus nerve, but the serotonin. So if you eat a diet that's high in tryptophan, there's so many ways the body deals with the tryptophan that there's not a direct relationship between your amount of tryptophan intake, which is obviously essential for your overall health, and the amount of good signals you get through your vagus nerve. That is not a direct relationship. It's this is one of the things that we talked at the very beginning. This brain-gut communication is a complex system. It's not a simple mechanistic pathway that goes from the gut to a particular region in the brain. It involves multiple pathways that interact.
What is the link between autoimmune disease and the gut? Or is there a link between autoimmune disease and the gut?
Yeah, so that has been there's been a lot of interest in the early programming of the immune system, which happens the first 3 years of life. That basically the immune system has to learn to differentiate between good and bad stimuli, between good and bad microbes, bacteria, and so that training happens early in life, and it's facilitated by a widespread exposure, by the exposure to a widespread number of stimuli. So if you grew up in a total sterile environment, your immune system would not have that education, what's good and bad for it, because it would never be confronted with something dangerous, or so it's more likely then that your immune system could, for example, attack your own cells. It would not be able to differentiate between your own cells and invaders, pathogens. So that's sort of been a big hypothesis about the origin of autoimmune diseases through the gut. And obviously, the gut is a place where a lot of this exposure happens. If you think about, and I couldn't give you now the actual numbers, but an extreme example, the exposure to all kinds of potentially harmful environmental stimuli that occurs in many places of India, where there's less hygiene. And I would say there's sort of two extremes. There's the US now, post-COVID, an extreme focus on constantly disinfecting your hands. And in many parts of Asia that I've traveled in, that's not been the case. Like you don't have to wash your hands before you eat something with your hands. And so the training of your immune system early on in life and throughout life is probably much more comprehensive in these places where extreme hygiene is not the rule. I mean, people haven't changed this, like interactions with pet animals. I mean, that's an important source of microbes that even an infant is exposed to, because infants play with the dogs and the dogs lick their face. And, that's a big lesson in this early programming. And that I don't think has changed. I think parents are not worried about that. Between humans, that's different, even though, in many cultures, hugging and kissing has not disappeared with COVID. I would say it's primarily focused on the hand washing, and what impact does this has on the prevalence in long term of autoimmune diseases. I mean, certainly our environments, I see this by young couples, like when I grew up, we spent a lot of time playing in the forest, coming in contact with dirt in the ground. So a lot of parents are afraid of that. They don't want their kids to sit on the sidewalk and get their hands. So there are dramatic changes that have happened. I don't know if this has been measured in terms of its impact on prevalence of autoimmune disorders. Some things that have changed independent of the epidemic of the COVID pandemic is, for example, the eradication of H. pylori. So H. pylori is an organism that has lived with humans for tens of thousands of years. It's one of those good bacteria, it's good microorganisms. It doesn't, um, it has lived in symbiosis with humans for a long time. It plays a role in programming the immune system to differentiate good and bad. So now, many areas in the US, we have eradicated it.
Yeah,
So we've taken away that lesson as well. And um,
yeah.
yeah,
Actually,
you know, I mean, vaccinations, I don't think have done the same thing. I mean, I'm a big supporter of vaccinations as opposed to some other movements in the US now that, but vaccinations are not interfering with this programming phase, this learning phase of the immune system.
yes. What?
But one thing, I
Mhm.
mean, one thing that I've noticed, so things like peanut allergies or all these other food allergies that people have nowadays, like when I went through medical school, that did not exist. So this definitely must have increased significantly.
Do you think that was triggered by leaky gut or problems with the gut, those increased incidence of allergies?
I think it's more related to this early programming, you know, because once you have a well-trained immune system that is good in differentiating from bad guys and guys that don't have to react to, certainly not your own, um, not your own cells. Once you've learned that, you don't unlearn it from a leaky gut. Yeah, I would say much more importance of the first 3 years of life, what happens there.
And you just spoke about H. pylori. What are your thoughts about H. pylori treatment? Now they treat it with multiple antibiotics and PPIs, especially that it has also high recurrence rate. What are your thoughts on that approach?
So I was much more involved with this field of gastroenterology, 10, 20 years ago when there was all the discovery of H. pylori and the emphasis, and even some of the people, there were some of the pioneers in that research have kind of changed their attitude towards is H. pylori eradication really a good thing? Um, there's no question that some forms, the more aggressive forms of H. pylori, have a negative effect and predisposed to
Yes.
um,
Yes.
yeah to gastrointestinal problems. But the great majority probably did not do that, and we've gotten rid of the kid with the bathtub, and sort of um, which is a typical thing in medicine. Once you have something that you can do something about, as a gastroenterologist, you will get rid of it, and patients have been kind of indoctrinated about the same thing, that they come to me and said, yeah, I have these GI symptoms, and I had H. pylori, but it was eradicated, but it didn't affect my symptoms. That happens a lot. I mean, like, it doesn't, in the majority of cases, positive H. pylori does not explain gastrointestinal symptoms,
But
and
but the concern also that untreated will increase the risk of gastric cancer. That's why they like recommend to eradicate it. But on the other hand, a lot of antibiotics, which just destroy the gut of the bacteria, and a lot of PPI is unhealthy, and then recurrence, and it's like a vicious cycle. So, from your point, should we eradicate H. pylori?
so I think by testing and only treating people with these more virulent types of strains of H. pylori would probably be the more prudent approach. Yeah, so in terms of antibiotic treatments or repeated antibiotic treatments, I'm in generally against that because it's the same thing, this phenomenon SIBO that has become a popular diagnosis. Um, I I think the damage done by these repeated antibiotic courses is it's kind of crazy nowadays that we know so much about the microbiome and how bad antibiotics are for the diversity and health of it. and what consequences a compromised microbiome health has on the gut and on the gut-brain system. I think it's crazy to treat people with bloating with antibiotics, and bloating and a positive breath test. They've all been questioned, their reliability and their accuracy and their specificity for an abnormality. So with H. pylori, don't take my word as the ultimate authority, because I've not really followed this further. Was a big thing early in my career, like endless studies, big studies that have shown, the benefits of eradication. But there were always comments that particularly more recently, that it was not a good thing to this eradication campaign, this non-specific eradication campaign, that the negative side effects of this is, but then we always learn, in medicine. So we jump on one treatment and then we do it for 10, 15 years, and then studies come out where this was not the right thing to do. And then we change the guidelines. I
Yeah.
think that may happen, yeah.
Yeah, it seems complicated. And the problem is now that they come and they just any abdominal discomfort, they want to test and it comes positive. And then it becomes like a cycle and the recurrence rate is very high. So you wonder, you should treat it and lower the risk of gastric cancer. But on the other hand, the recurrence higher and you just keep killing the bacteria.
And also the question is, what other cofactors enhance the risk of gastric cancer? So typically it's not one thing. I mean, I always think along these lines that it's really not one organism that causes gastric cancer. There's a combination of factors. And, for example, with peptic ulcer disease. So peptic ulcer disease is now being treated with H. pylori eradication. But there's many studies that have shown its interaction of chronic stress with a positive H. pylori finding that is necessary, to develop a peptic ulcer. And we don't deal with the stress part of it. And what we know from stress, for example, the norepinephrine that's being released from sympathetic nerve fibers that also innervate the stomach, they can affect the virulence genes of many bacteria, both pathogens, but also benign bacteria. And so with peptic ulcer disease, many studies have shown that stress plays a role, but it's not sufficient. You have to have that stress part and the H. pylori, because the H. pylori becomes more virulent, and then that causes but if you've dealt with the stress part, which in medicine we're not really very good in doing, then yeah, there would be a higher likelihood of developing an ulcer. And I mean, that approach has been successful. I mean, like when I first trained at UCLA, peptic ulcer disease was one of the most important diseases in gastroenterology, and that has almost, vanished as a major problem, because H. pylori is being eradicated. We didn't deal with the stress part, but H. pylori is being eradicated.
What do you recommend after a nasty stomach infection to promote gut recovery and healing?
Yeah, I would say I personally recommend a course where you go on or we add to your diet a variety of naturally fermented foods. And that has been shown, to increase the diversity in a very good study. That also been shown to decrease inflammatory mediators. And if the patient doesn't mind eating fermented foods, if you go on that regimen for a month, you will improve your gut microbiome that's been compromised by the infection or by a course of antibiotics. You could also say, you take a probiotic supplement, and there's some evidence, that may also be successful, but there's also been a publication to the opposite, that it will delay the recolonization of your gut with your own microbes. So if you take a high dose of this probiotic, billions of CPUs, then it will take longer before your own microbes reestablish themselves. So I typically go with the dietary recommendation, take at least 3 different types of fermented food types, each of which has a different combination um, of probiotics in it. You know, um, so one of the best ways you could do this is like if you go to a Korean restaurant and in addition to the main dish, you get like 30 or 40 side dishes with fermented foods, from fish to vegetables to dairy products. But you don't, obviously, if you don't need to do this. I think if you pick, a couple of dairy products and plant-based fermented foods like kimchi, that will do it. And I've seen many examples where this has been successful.
Are there specific probiotics that are best for specific condition? And are there also specific probiotics after a stomach infection?
Yeah, there's a lot of marketing out there, with different, most of these, so the species in these, or the genera that these commercially available probiotic supplements are available in is bifidobacteria and lactobacilli, 95%. They use different strains of these two genera in different products. In very few instances has it been demonstrated that actually makes, in a controlled study, in a randomized controlled study with placebo, that makes a difference. There's obviously a big placebo, effect in it. I would always say, some patients come to me and say, yeah, I took this probiotic and it really helped me. And I said, well, that's good. So it's good for you. Maybe your unique microbial composition or ecosystem is particularly conducive that this probiotic is helpful. The majority would say they don't really know if it makes a difference. And to those, I would say, well, try the multiple fermented food intervention, which is good for your gut health anyway. You don't just need to do it for um, after an antibiotic course or an infection. I was sort of curious. I'm not familiar with the Mediterranean, not the Mediterranean, the Middle Eastern cuisine. I mean, do you have fermented foods as an important part of it, or not necessarily?
I mean, they love yogurt here with the food. They like to mix it with the rice. I mean, rice is not healthy, but it's part of the diet here and the culture. I believe yogurt mostly is the most fermented. I can't think of top of my mind other fermented food that they
Mhm.
eat here. What are other examples of naturally fermented food that are very good for the gut?
Um, I mean, in that study that I quoted earlier, where they showed there was a beneficial effect on inflammatory mediators, the main and then this was based on food, frequency questionnaires. The main fermented food type was fermented dairy products like yogurt or kefir or um, um, and I mean there's kimchi, which is basically, which is the most popular amongst Koreans,
Yes.
which is fermented vegetable. It's good because it has almost 0 calories. Um, there's kombucha, which is a tea, fermented tea, which is also common
Asia.
in yeah, in Asia. Asians in generally have the most diverse variety of these fermented foods. And I'm, because they've done it for thousands of years, I'm convinced that our
Perhaps
genes,
why this is why they live longer.
that may be one of the reasons, and their genes have adapted to this. So, if anything that you do in terms of your dietary preferences for more than 5, 10,000 years will affect genes, and I'm sure many Asians have genes that are specialized to interact with with these probiotics.
When I spoke to Dr. Dayspring, and he's one of the world leader on the lipidologists, we discussed how cholesterol metabolism can arise from two mechanisms. One of them is over-synthesization of cholesterol in the liver, and the other one that intestine overabsorbs cholesterol. And as a gastroenterologist, what is your perspective? Why would the liver over-sensitize cholesterol, or and also why would the intestine overabsorb cholesterol?
I can't give you an expert opinion on this. The one thing that I've learned from from experts in this space, your cholesterol level is less influenced by the diet as it is by metabolic disturbances that we have without generally unhealthy diet. So it's not the cholesterol in the butter or in the cheese. It's the general metabolic disturbance that so many of us have, this metabolic endotoxemia, so this low-grade inflammation, that's a much more important factor in influencing your blood lipids and your your cholesterol. But it's a very superficial answer to your question, but I've heard this from many experts in the field. So, like, when I went to medical school, the thing was, okay, you have to eliminate butter, you have to eat margarine. That has actually not panned out. It's not. I mean, in general, I would say plant-based fats are healthier than animal-based fats, but so these cholesterol poor diets, it's not an answer to if you have abnormal cholesterol levels. I think what it always comes down to a generally healthy diet, which is, I would say, it's the human default diet, based on thousands of years of human consumption in our ancestral diet. That will be the best thing for your metabolic health, for microbiome health, and for your immune health. That's the details of that, and the ethnic and national variations of that diet is pretty less important than just these main components. 70% plant-based, and meat coming less from red meat, or protein coming less from red meat and more from fish and poultry. There's some people, a growing number of people in the US, that promote the vegetarian diet. The studies have not shown that the vegetarian diet per se is significantly better than a Mediterranean diet. But there's other reasons, there's ethnic reasons, mistreatment of animals, and all the areas that, I mean, influence my own behavior. But for a lot of people, that's not an issue.
You talked about the low grade inflammation plays a role in many diseases, and the gut, the intestine has a huge amount of influence on the immune system. How to decrease low grade inflammation, and how to stop the cytokines from overactivation?
Well, it's a big part of this, as we understand it today, is clearly the diet. To go from we call the standard American diet, and I imagine in the Middle East there's a lot of meat consumption. I imagine I don't know about other components. I mean,
Lots of
is
rice.
there, yeah, I personally would say that, like you mentioned, bread and rice, that per se may not be
the best.
that unhealthy. They may not be that unhealthy. If you look at the origins of the Mediterranean diet in Crete, and even nowadays, if you go to Mediterranean countries, there's a lot of bread, pasta, pizza, a lot of carbohydrates, and um, so that per se is not something that is bad for your metabolic health, I would say. It seems like all the evidence is pointing towards this ultra processed diet and the increased intake of sugar, not complex carbohydrates, but sugar. So I would say rice. Also, there's many countries like Iran, for example. Also rice consumption is a big part of it. And I mean, there's a lot of people that live into their 90s and hundreds in Iran on that diet. It's not, but I think the most harmful parts of the Western diet is one, the portions are too big, be at the high degree of ultra processed foods. Up to 60% of people are now consuming this kind of food with all these chemicals and sugar in it. So yeah, it's kind of interesting. I mean, I know, in your country, metabolic diseases are pretty common.
Yes.
Um, But I mean, I wonder how much of that is the westernization
Yeah.
of the Middle Eastern diet, or how much.
Western diet have moved here with all of the big brands and big branches, and also they love dessert here, and lack of exercise as well among many other
Yeah,
factors, but mainly the diet.
yeah. I think this whole demonization of carbs. So I mean, there's some people who say carbs are always bad. I mean, this
Yeah,
is this is completely wrong.
yeah, refined. Mm.
It's the refined ones, because many complex carbohydrates go down to the microbes and are foods for the microbes and have beneficial effects. Sugar does not. I mean, there's no sugar going to your colon. It's all rapidly absorbed in the proximal small intestine, and that's kind of the main issue. You're starving your microbes with a high sugar diet, and you're preventing them from producing these butyrates, these anti-inflammatory butyrate molecules. Um, and yeah, there's definitely a lot of good complex carbohydrates. Most of them are good for your health, I think. Um, but there's almost nothing you can say positive about sugar other than the taste experience. And
Yes.
yeah, so exercise is clearly the other one.
Mhm.
Regular aerobic exercise and weight-bearing exercise is clearly, it's not the only. So if you eat unhealthy and exercise, it won't have the side effect. You're probably not going to lose weight, and your metabolic health will not necessarily improve. No matter how, even if you're a marathon runner, that will not guarantee your longevity. There's even many examples of marathon runners who die in their 50s, and but it's the combination. And again, what we talked earlier about the brain, it integrates so many factors. Your metabolic system does the same thing. It's the exercise, it's the mental state. So stress by itself, chronic stress can cause inflammatory changes and a leaky gut. Um, I would say all the factors that we have studied converge in some ways on this brain gut microbiome system. So with moderate but regular exercise having a positive effect, with chronic stress having a negative effect, with diet can have a positive or negative effect. So they all interact with each other. So ultimately, it's your lifestyle.
Yes.
I'm I'm not I'm not promoting this idea that, yeah, eat a healthy diet and live into your hundreds. It's just not. Even this person I recently interviewed on the podcast, Dan Buttner, the Blue Zone person, he came to the same conclusion. Initially, it was thought it's the diet of these areas of the world that live into the 90s and hundreds. But in the meantime, this has been expanded into human connectedness, exercise, um, diet being one part of it, not the only one.
Yeah, so diet and exercise and chronic stress. And is there any probiotics or anything else you recommend?
Not outside of, so my dietary recommendations now are, the 70% plant-based, avoidance of ultra-processed foods, and the implementation of a regular regimen of naturally fermented foods. I mean, that's kind of what it boils down to for me. But not, if somebody doesn't have access or just hates the taste of fermented foods, you may try a probiotic. And there's some, that have been better studied than others, I would say, but the differences are relatively small. The differences are mainly in the marketing. Some companies have been more
More
successful
success.
with the marketing than others. Yeah.
Could you tell people about your book and your YouTube channel, and where can people find more about learn more about your work and what you do?
Yeah, so the simplest way get information about myself and the books and publications and podcasts is to go to my website, emeranmayer.com. And there's a whole range of things that you can sign up for. Membership, which I encourage because then you're a regular recipient of the information. I have a podcast, the Mind Gut Connection podcast, where I talk to pretty interesting and impressive people in that space, in the wide space of brain gut microbiome interactions, longevity, and health and diet. We've also we've been involved in a couple of films, made this documentary on PBS, which you can also order on the website, on the brain gut microbiome system. And I was invited to be part of a special on masterclass.com, which is also a really good piece of information. So these resources can be obtained from the website.
Yeah.
We also have this newsletter, which we publish on a regular basis. And yeah, I would say somebody who's really interested in this topic and in their health, I would strongly encourage them, go to the website, become a member, and get our information on a regular basis.
Yes, we will link your website, and also I recommend reading many incredible books that you have as well, and your YouTube channel also, which I also watch.
Oh, I should mention one thing.
Mm.
So our latest edition is this Mayer nutrition component of our program, and we've just launched the first product, which is which is actually a supplement of multiple polyphenols. So these molecules that I told you about are major elements, health promoting elements in plants and vegetables and fruits. And we've realized that the majority of patients or individuals in the world, particularly in America, are totally under consuming these molecules, and because you would have to eat a regular amount of fruits and vegetables every day to get the optimal level. So an easy way to do this is, taking this supplement. And as I said, we've just launched it recently, and I would also recommend this to people who are interested in there.
Yes, and where can they find this supplement if they want to?
They can find it on the website, mayernutrition.com.
Well, Dr. Mayer, thank you very much for sharing your time and knowledge and for helping us understand the mind and the gut and transforming our understanding through your research and work. And it has been an incredible honor to have you here on the show.
Yeah, it was a pleasure. Anytime that there's an opportunity to actually take that message to the Middle East, I would be delighted to do it.
Yes, and we're happy to share your teaching here and would love to have you back sometime in the future.
Okay, sounds good.
Sounds good. Okay, thank you very much.
Bye-bye. Good talking to you.
Take care.